Now let us see the method of ascending an alcohol, that is CH3CHO. Now for ascending we have to include one carbon atom, and that is provided by hydrogen cyanide. Aldehydes and ketones can add on hydrogen cyanide in presence of alkali to form what is called as cyanhydrin. So HCN splits into H positive, Cn negative, C double bond O ionizes as C positive, O negative, connecting to H positive, Cn connecting to carbon, cyanhydrin is formed. This on hydrolysis. In presence of acid or alkali, the cyano group is getting hydrolyzed to COOH. Now we have to remove the OH group. For that we react this molecule with 2 molecules of HI. Now CHOH group there reacts first with HI producing water, and this iodine gets united to this carbon, so CHI. A second molecule of HI will react, a molecule of iodine is removed, and we get CHH, that is CH2, that is a method. Then you convert this acid into the corresponding acid chloride using phosphorus pentachloride. The OH group in acid is similar to the OH group in alcohol in this reaction, so that OH is replaced by Cl. COCl is formed, acid chloride it is called. So the acid chloride is prepared by reaction with the PCl5. The OH group is replaced by chlorine. Now here cyanide is hydrolyzed and here OH is being removed. Then hydrogen vanadium barium sulfate, this reaction is called Rosenmund reduction. Then H connects to carbon, H connects to chlorine, and we get CH3CH2 CHO. So ascending the series. And descending an alcohol, descending an aldehyde, the aldehyde CH3CH2CHO is oxidized using acidified potassium dichromate or alkaline KMnO4. CHO is converted to COH, then it is reacted with sodium hydroxide to produce sodium acetate. It is crystallized and dried, and dry sodium acetate with soda lime. Soda lime is an intimate mixture of sodium hydroxide and calcium oxide, and their sodium hydroxide is the reacting species. Calcium oxide makes it dry, so keep it dry. And during this reaction, COONA combines with NaO, Na2, CO1, O2, O3 is removed. The remaining H combines with this CH2, producing CH3, and this is subjected to free radical chlorination using ultraviolet light and chlorine. One H atom is replaced by Cl, we get CH3CH2Cl, then NaOH. CH3CH2OH is formed. This primary alcoholic group is converted to CHO by reaction with the pyridinium chlorochromate. Now, ascending and descending of ketones is difficult. A large number of reactions are involved, so we'll see it later. Now, let us see some conversions. Now first conversion, that is 3-nitrobromobenzene to 3-nitrobenzoic acid. Now here bromine is given preference 1, 2, 3, 3-nitro, 1-bromobenzene. Now the method is to convert this compound into a Grignard reagent. And for benzoic acid, we have to introduce the COOH group, so one carbon is necessary. Now Grignard reagent can add on to carbon dioxide. The MgBr part becomes the positive and the phenyl part becomes negative. CO bond ionizes as O negative and C positive, so that this phenyl group connects to this carbon and MgBr connects to oxygen. So there is a C double bond O left, C double bond O MgBr, phenyl being connected to the carbon. Then next stage is hydrolysis, chemical reaction with water. OMgBr bond breaks, H and OH, O minus, MgBr positive, O minus gets connected to H positive, and OH negative connects to MgBr. So we get metanitrobenzoic acid. Now there is another question. 4-methyl acetophenone to benzene 1,4-dicarboxylic acid. This is 4-methyl acetophenone. So CH3CO group is acetyl group, and hence the name aceto. Since it is a ketone of phenyl and methyl, it is called acetophenone. Then there is a methyl group at position 4, 1, 2, 3, 4. Now, a specialty with such compounds is that the carbon directly bonded to the benzene ring is never getting free, because these carbons are bonded to a stable aromatic system. This carbon is broken away as carbon dioxide and water by the oxidizing agents, acidified potassium dichromate or alkaline KMnO4, followed by acidification, because alkali will give the sodium salt of this acid, and on acidification free acid will be liberated. So this carbon is oxidized to carbon dioxide, this hydrogen is oxidized to water, whereas here we get COOH and extra hydrogens are oxidized to water. So oxidation for the entire chain occurs. Here also for the entire chain occurs, group occurs. Here also for the entire group occurs. The extreme oxidation state, that is COOH, is attained on both directions, in both groups, and we get benzene 1,4-dicarboxylic acid. It is also called terephthalic acid. Now how will you convert cyclohexene to hexane 1,6-dioic acid? Now here the reagent used this alkaline KMnO4 for heating and then acidification, because alkali NaOH will produce the sodium salt. So on acidification we get the free acid. Here the double bond is the delicate part, because the pi bond is weak. So first of all we get two OH groups connected to the carbon. Then see, permanganate oxidations are written as H2O plus O. Alkaline KMnO4 is equivalent to H2O plus O, and this is equivalent to OH. It is not hydrogen peroxide, but an equivalent, that is all. Now one OH will be connected to this carbon, and another OH to this carbon, and we get. Now this bond is broken, and one more OH here and one more OH here. And to the same carbon we have now two OH groups. and then one OH will be removed as a molecule of water, another OH as a molecule of water. So we get here this carbon is converted to CHO, and here this also converted to CHO. Now permanganate again oxidizes CHO to COOH. So that is the sequence of reaction. First formation of a diol, then breakage of this diol bond, carbon-carbon bond connected to these OH groups. Then addition of two OH groups more, so that these two carbons are now free. There is no bond. Removal of water to give aldehyde groups, and then further oxidation to carboxylic acid group. So it is hexane 1, 2, 3, 4, 5, 6, 1, 6 dioic acids. Now benzyl alcohol to phenyl acetic acid. You must know what is phenyl acetic acid and benzyl alcohol. Acetic acid in which one hydrogen atom is replaced by a phenyl group is called phenyl acetic acid. Benzyl group is C6H5CH2 benzyl alcohol. So there is one carbon in excess in phenyl acetic acid. So one of the reagents must be potassium cyanide. This alcohol on reaction with PCl5, we get the corresponding Cl. Potassium cyanide, Cl is replaced by Cn minus KCl, Cn. Hydrolysis in acid medium produces COOH. So simple sequence of reactions. Draw the structures of the following derivatives. 2,4-dinitrophenyl hydrazone of benzaldehyde. Simple. You draw the structure of benzaldehyde. Phenyl hydrazine is 2,4-dinitro. So this is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. 2,4-dinitro phenyl hydrazine. Now here the S2 of NS2 group combines with the oxygen of CHO, and you get CH double bond N NH, then the remaining thing. So this is the 2,4-phenyl dinitrophenyl hydrazone of benzaldehyde. Cyclopropanone oxide, you take cyclopropane. This is cyclopropane containing 3 carbon atoms. Now here there is a CH2 group bonded to another CH2 group, bonded to C double bond O. So this molecule is written like this. So it is a triangular shape, then double bond O is there. Removal of water, we get dioxide. C double bond NOH, and this is oxide. Acetaldehyde dimethyl acetal. Now dimethyl acetal means the alcohol used is methanol. Acetals are formed when alcohols react with aldehydes in presence of HCl gas. Now dimethyl means the alcohol used is methyl alcohol. So CH3OH, the CO bond polarizes to C positive and O negative. H positive connects to oxygen, O, CH3 connects to carbon, C halves OCH3 and OH. Now second molecule of methanol can react with the OH. A molecule of HOH is getting removed, and then we have another OCH3 group. So it is dimethyl acetal. Acetaldehyde dimethyl acetal. The ethylene ketal of hexane 3-on. Hexane 3-on, you write the structure of hexane 3-on. 3, 4, 5, 6. On third carbon you write the carbonyl group double bond O. Now ethylene ketol means the reaction product between ethylene glycol and this ketone, ethylene glycol. That is CH2OH bond CH2OH. Gly indicates 2. So ethylene glycol may be represented like this line formula. Now the oxygen atom of the carbonyl group combines with the 2 H atoms producing water, so removal of water. HCl gas is the reagent, just like the formation of hemiacetal and acetal. And this oxygen atom binds to this carbon and this oxygen binds to this carbon because there is 2 valency remaining over this carbon. So with 1 valency it bonds to this oxygen, with other valency it bonds to this oxygen, we get a cyclic structure. And this is the ethylene ketol, K-E-T-A-L. The methyl hemiacetal of formaldehyde. Again, the methyl means the alcohol used is methyl alcohol. Hemi means there is only 1 alcohol used. If you use 2 alcohols, we get the acetal. So as usual, CO bond ionizes. These ionizes are H positive and O negative. H positive connects to oxygen, O negative connects to carbon. So this is the hemi acetal. Predict the products formed when cyclohexane carbaldehyde reacts with the following reagents. Now cyclohexane is this one and this is carbaldehyde. So this molecule is called a cyclohexane carbaldehyde. The name aldehyde, the suffix used is carbaldehyde, carboxylic acid, carbaldehyde. Phenyl magnesium bromide is this one, a Grignard reagent and on addition to aldehydes. See, when a Grignard reagent is getting added to formaldehyde, we get a primary alcohol. When a Grignard reagent is getting added to an aldehyde other than formaldehyde, we get a secondary alcohol. This is not formaldehyde. So we should get a secondary alcohol. The secondary alcoholic group is CHOH group with 2 valencies. So phenyl part becomes negative and MgBr part becomes positive. This ionizes, O becomes negative and O becomes negative and C becomes positive. And this negative phenyl part connects to this carbon, CH carbon, OMgBr. Then hydrolysis. Hydrolysis means breakage here. H positive comes here and OH negative comes here. We get the secondary alcohol. Now the reaction between cyclohexane carbaldehyde and Tollens reagent. Tollens reagent may be simply written as Ag2O. Ammoniacal silver nitrate solution, that is Tollens reagent. It is having the formula AgNH3 twice having a positive charge and NO3 negative. Anyway, the reacting species is Ag2O. This aldehyde is getting oxidized to cyclohexane carboxylic acid plus 2 Ag, and this is a test for aldehydes, and this molecule is cyclohexane carboxylic acid. Cyclohexane carbaldehyde, cyclohexane carboxylic acid. Now semicarboside and weak acid. Now here, first of all, semicarboside donates a lone pair to the carbonyl carbon, which ionizes as C positive and O negative. Then when lone pair connects to this carbon, one electron is given to this carbon. So during ionization, it should get a positive charge, but that positive charge is neutralized by donation of a pair of electrons. And NS2 group becomes positive, O becomes negative. Now here an exchange occurs and its positive goes to this O negative, so that both groups neutralize their charge and we get OH, NH. Now in slightly acidic medium, the OH group is protonated to OH2 positive. It's a good leaving group. And there when OH2 positive is removed, like this arrow shown, this bonding pair is taken up by the OH2 positive part. This NH bond will be shifting in this direction, releasing H positive, so that acid is a catalyst, and we get CH double bond N, NHCO, NS2. This is called semi-carboside. Now I told you why this NS2 is not acting as a nucleophile, even though it possesses a pair of electrons. Now the thing is that this pair of electron is given to resonance with the carbonyl group. So this is less available for donation to this carbon, because it is moving along this chain. Now excess ethanol and acid here is HCl gas, that is not mentioned. We get the acetal. CO bond ionizes, H positive connects to O, or C2H5 connects to carbon. We get this hemiacetal. And then further the OH here will react with another molecule of ethanol, removing a molecule of water, and we get what is called acetal. So that is the reaction. Now cyclohexane carbaldehyde on reaction with the zinc, amalgam and HCl. Now the reaction is one of reduction reaction. A CHO or CO group is converted to CH2 group. So you hear CHO, CH double bond O. This oxygen atom is removed by reduction. 2 H atoms combined with this oxygen, and the valencies are connected to 2 H atoms, so that we get a CH2 group instead of CO group, and when this combines with H, total of CH3 group is produced, and this reduction reaction is called Clemenson's reduction. How will you convert ethanol into the following compounds? Ethanol is acetaldehydes, two carbon atoms, parent is ethane, hence the name ethanol. To butane 1,3-diol. Butane 1,3-diol is shown here. This is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. Now the simple reaction is aldol reaction with dilute NaOH alone. Addition reaction occurs. Now here CH bond ionizes, here it ionizes to H positive and CS2 negative. So this reaction occurs H positive, CS2 negative. Here this reaction occurs O negative, C positive. Now CS2 negative CHO connects to this carbon and O negative connects to this hydrogen. So we get CHOH, CS2 CHO. Now this on reaction with lithium aluminum hydride, this CHO is reduced to CS2OH and this compound is butane 1,3-diol. Now will you convert ethanol to butenol? It is nothing but aldol reaction again, and butenol, 2-in-1-ol, butenol, that is this compound. Now when reaction with the dilute NaOH and heat, a molecule of water is removed. This reaction is called condensation. Reaction between two molecules eliminating a molecule of water or NaCl or HCl, etc. Simple molecules like water, ammonia, HCl, NaCl are removed when two molecules react to give a product. Is called condensation reaction. Aldol condensation reaction. Condensation occurs here. CH double bond CH, CHO, and this is the required products. Now coming to a problem. An organic compound with molecular formula C9H10O forms 2,4-DNP derivative. So it might be an aldehyde or a ketone. Reduces tolerance reagent. So it is evident that aldehyde is the compound because ketones cannot reduce tolerance reagents, and undergoes Cannizzaro reaction, means it does not possess an alpha H atom. On vigorous oxidation, this is the important point, on vigorous oxidation it gives 1,2-benzene dicarboxylic acid. So C9H10O, vigorous oxidation, we get benzene 1,2-dicarboxylic acid. So the compound should be an aromatic aldehyde or a derivative of benzaldehyde in which the second position is substituted by another group. So benzaldehyde is C6H5O, CHO. When one more position is substituted, means the formula reduces to C6H4CHO because the hydrogen atom in the second position is removed and another group is introduced. We have to find out what is the second group. For that we have to remove the H atom in the second position, then the formula changes to C6H4CHO. So you subtract this formula from this one. C9H10O minus C6 plus 1 C7H5O. So C9H10O minus C7H5O. That will give C9 minus C7 is C2, H10 minus H5 is H5. So this is an ethyl group. So the compound must be, shall write here, CHO, C2H5 can be split as CH2, CH3. So it is 2-ethyl benzaldehyde. Now let us stop here. We shall see the remaining exercises in the next video. Thank you.